Getting familiar with metals. Introduction. Any welding endeavor is much easier if you have a solid working knowledge of metals. The more you know about the metals you're using and how they're likely to respond to the intense heat involved in welding, the more likely you'll be able to manipulate and join them in the way you have in mind for a specific project. You probably remember from your high school science class that, like other materials, metals expand when you heat them and contract as they cool off. If you heat them enough, they start to get soft, and eventually, with more heat, they melt. I know that sounds simple, but it's awfully important for welding. Some metals melt at relatively low temperatures, and others have extremely high melting temperatures. A metal's melting point is just one of several important properties for welding. Here are just a few others to consider. Ductility is a metal's ability to change shape, bend, stretch, and so on, without breaking. Gold has a high level of ductility, while tungsten isn't very ductile at all. Electrical conductivity is a measure of how well a metal can conduct a current of electricity. Copper conducts electricity really well. By comparison, stainless steel isn't a great conductor of electricity. Strength is pretty self-explanatory. How much external force can a metal withstand without breaking? This one is very important for welding. Steel is a strong metal, but zinc isn't. You can read up on many more properties of metal, and the more you know, the more easily you can make smart decisions about how to weld those metals effectively. Not all metals are widely used for welding, of course, and you probably won't work with a huge range of metals in your welding shop until you've been welding for a while. That's completely fine, however, because plenty of exciting welding projects, both fabricating and repairing, involve only a few select metals. See why welding matters earlier in the chapter for more on those divisions. For example, most of the welding practice exercises I walk you through in this book, as well as the welding projects I detail in Part V, focus on 3 metals: steel, stainless steel, and aluminium. These 3 are the most commonly used metals for beginning welders, and you should take the time to get to know them. In the following sections, I give you a quick look at each one. Steel. Steel is a strong, versatile metal that you use all the time in your welding projects. You may not realize it, but steel is really an alloy made up of iron and less than 2% of another material. Carbon is often used in steel alloys, and you can find 3 different levels of carbon steel: low dash, medium dash, and high carbon steel. The more carbon in the steel, the stronger the alloy is. You should use steel in your welding projects when you're looking for a strong metal that's pretty easy to weld and doesn't break the bank when you're buying your materials. You can use any welding process I describe in this book on steel, so versatility is also one of its strong suits. But steel also has its downsides. For one, it's heavy. If you want your fabricated project to be light, steel probably isn't your best bet. Steel is also prone to rusting and scaling, flaking off due to oxidation, so you have to spend a fair amount of time cleaning it up, often with a grinder, before and sometimes during welding. Stainless steel. Stainless steel is amazing stuff. It has a lot of the good qualities that regular steel has, see the preceding section, but it also offers one added bonus. It resists corrosion, rust, for instance, like a champ. You can put a piece of stainless steel out in the yard and let it get rained on for 6 weeks, and when you bring it back inside it probably won't have a single spot of rust on it. Incredible. How does stainless steel provide such remarkable resistance to corrosion? Its alloy contains 10 to 30% chromium, the rest is iron, although sometimes other metals, such as nickel, are also added to the alloy. You can weld stainless steel with all 3 of the major types of arc welding: stick, MIG, and TIG. It's a great choice if you want your project to resist rusting or to have hygienic surfaces, those that don't harbor bacteria and other microscopic critters. Stainless steel is pretty expensive compared to other commonly welded metals, so be prepared to open your wallet a little wider if you choose stainless steel for a welding project. Aluminium. Like stainless steel, aluminium is great at resisting corrosion. And aluminium offers another pretty terrific characteristic. It's lightweight. Compared to steel and stainless steel, aluminium is a real featherweight. Pure aluminium is a popular choice for welders, but aluminium alloys are also frequently used. Copper, manganese, and zinc are just a few of the metals that are often alloyed with aluminium to produce enhanced characteristics in the finished product. If you are going to be welding aluminium, I recommend going with TIG welding. It just makes for a cleaner, easier job. If TIG isn't an option, take MIG welding. You can stick weld aluminium, but it's not ideal. Your choices for stick electrodes are going to be limited, and you are probably going to have a difficult time maintaining the correct arc length.